All right, today we're going to take a look at 7.3b. We're still on the 3 equations, 3 variable problems. So settle in. Of course, these take a lot of work, as we know, but we're extra lucky today because they are in word problem form. That's right, application problems. So we're going to have to read the problem and, of course, write our own 3 equations and then go back through and solve these. But let's kick it off with just reviewing how to solve just 3 equations, 3 variables when they give them to you. So first, of course, you know I like to make sure everything is nice and neat and organized so we don't mess up anywhere. So I'm just going to label my equations 1, 2, and 3. Hang on, ignore the bell. All right, ignore the bell there. Okay, so I'm looking through the x's. I've got 3, 1, 5. That's not so bad. Y, 3, 2, 8. Z, I see a 13. Forget it. So I'm going to get rid of the x's. So I'm going to start with the first 2 equations. So I'm jotting down the first one. You could have, if you wanted to, divide the first one by 3. Make your life a little easier if you wanted to. I'm going to go ahead and multiply the second equation by -3 so I can eliminate the x. -3 times 2, -3 times -3, -3 times 5. All right, let's add these together. -9y, 9z, and then, of course, -15. All right, now we have to do something with our third equation. I have not touched that, so I'm going to jot that one down. And of course, if I took x out of the red system on the left, I need to eliminate x out of these green ones. So I'm going to make a good choice here. To eliminate x, to get rid of that 5x, I'm going to put the second equation with it, but I'm going to multiply it by -5. So I'm going to have -5x, -10y, +5z, -25. Okay, let's add these together. So -18y, 18z, and of course, -18. A lot of good stuff there. Now, both of these equations, you could reduce them if you want to make your life easy. The red one, I'm going to cut everything by 9. Or not 9, sorry. How about 3? Let's reduce by 3. Getting carried away here. 3 goes into 9, 3 goes into -15, 5. And if you want, you can reduce our green one. We can reduce everything by 18. All right, we're going to pair these 2 together in the middle and make a system. So I'm glancing through them right now. Let's get rid of, it really doesn't matter. We're going to have to multiply the green by 3. More importantly, actually, I'm going to do -3, and then I'm going to stack it underneath. So -3 times -y, so that will eliminate, so will this. -3 times -1. Let's add them up. So everything on the left eliminates. 5 plus 3, 8. 0 doesn't equal 8. We know that. This is one of our no solutions. So just a quick review, of course. 3 equations, 3 variables. We're going to see more of them coming up in word problem form. As always, my advice, write small. The height at a time of the t of the object moving in vertical line with constant acceleration, a, given by that equation. The height is measured in feet, t is measured in seconds, v sub 0 is the initial velocity at time 0, s sub 0 initial height. Find the values of a, v0, s0, f. Okay, so much. So here, s is 52 times 1. I'm going to make the first equation out of this. So clearly I'm going to put 52 in for s. I'm going to replace the t with 1. So my first equation, 52 in for s, and then I'm going to replace the t's up here with 1. Now I know some of you can do the simplifying in your head. That's totally fine. I'm just going to write it out for right now. Okay, so I'm going to, of course, simplify those 1 squared. I mean, who needs 1 squared? 1 squared, 1 times a half. Let's make it look nice. Who needs v sub 0 times 1? I'm just going to leave it v0 and then s0. So there's my first equation. Okay, my second equation from the second piece of information. So this time I'm going to put 52 in for s again, same 52. But this time it says that's at 2 seconds. So I'm going to replace all the t's now with a 2. So I'm going to have half a times 2 squared. Yes, I know you know what 2 squared. But I'm just going to jot it down for right now, times 2 s0. Now I'm going to clean these up. So 2 squared, of course, 4. 4 times the half. Let's make this 2a. And I'm just going to reverse the order, 2v0, s0. All right, third equation from s is 20, t is 3. So now s is 20, and I'm replacing the t's with 3. So 3 squared v sub 0 times 3. Okay, so let's simplify this, of course. 3 squared 9, 9 times a half, 4 and a half, 9 halves, however you want to put it, I don't care. And then 3 times v0. All right, got it. So that's the work just to get our 3 equations. Holy enchilada. So I'm going to kind of section that off. Now we have to solve that system. So I'm looking through my variables, which are a, v0, s0. Probably the easiest to eliminate is the s0, because they're all one s0. We're just going to need a sign change. So I'm going to start with my first equation. Now we're used to having the variables on the left, so I'm going to put the half a, the v0, the s0 on the left, and just flip-flop it, put the 52 on the right. Now, let's go ahead, let's just make it easy. I'm going to pair up my second equation with it, but I'm going to run a negative through it. So the second equation, I'm using the green one, 2a, and we get negative 2a, negative 2v0, negative s0, and negative 52. Okay, let's add these together. A half minus 2, a half minus 2, negative 1 and a half. v0 minus 2, v0. S0's cancel. Got it. Clearly, we need to do something with equation 3. So I'm going to jot that down. Again, I'm going to put the variables on the left like we're used to. And then we equal 20. Now, it doesn't matter which equation we put with it. This might seem counterintuitive, but believe it or not, I want to do the first one that has that half in it, because when I run a negative through it, I think we'll come out with a nice whole number with the fraction work. So I'm going to have negative a half a, negative v0, negative s0, negative 52. Because 9 halves, 4 and a half minus 1 half, 4. See, that's what I was thinking was going to happen. 3v0 minus v0, 2v0. These are gone. 20 minus 52, negative 32. Now, if we wanted to, I see my blue equation, 4, 2, 32, all even. Let's divide them by 2. 2 goes into 4, 2 into 2, 2 into 32. Okay, we're going to put our red and our blue equations together. Nicely, I see the v0s are going to cancel. I'm just going to stack the blue one underneath, just to try to save a little bit of writing. We're all about that. Okay, let's add these two together now. So negative 1 and a half plus 2, a half. v0s are gone. 0 plus negative 16. And then, of course, to get rid of the half, you're going to divide it off or multiply by 2. If we multiply by 2, a negative 32. I'm going to circle that because I don't want to lose it, okay? And all of this crazy work. Now, it's that back substitute game. Go back to anything on the right side of the screen in red or blue and figure out v0. I'm going to go back to this blue equation on the side here. I know a is negative 32, so I'm going to substitute that in. 2 times negative 32, I'm just going to do it in my head, plus v0. And then I'm going to add the 64 over. So negative 16 plus 64, 48. I'm going to circle it so I don't lose it. Okay, clearly, last thing we're missing from our variables, we need S0. So I'm going to go back to an equation that has S0 in it. One of the originals on the left side of the screen. I'm actually going to do this middle equation in green. I'm going to go through and I'm going to replace the A with a negative 32, and I'm going to replace the V0 with a 48. And then we can figure out, of course, what S0 is. So I'm going to jot that down. Actually, let me hit extend page and we'll scroll this down a little bit so I don't totally run out of room here. Okay, so let me rewrite that. I'm going to section this off here. So 52. 2 times negative 32, negative 64. 2 times 48. And then, of course, you're going to add the 64. You're going to subtract the 96, go through and solve it, and we'll end up with S0 is 20. Now, one last thing I'm going to do. It says, of course, to find the variables, and then, of course, more work. It wants the equation, the final answer, the equation. So we're working off this original one at the top. I'm just going to jot it down so it's on our screen here. S0. Okay, so we know A now. So I'm going to replace A with negative 32. V0 was our 48, S0 was our 20. And then I'm just going to simplify this, circle it, and finally be done. Okay, half of negative 32, of course, let's make that negative 16. We got my 48t and my 20. Got it. So there is my final equation. It says give the position equation. We got it. We're going to need that too today. Whew, that was a good one. So, I mean, you look at your homework, I didn't give you very many problems, but clearly they are time consuming. All right, well, let's take a look at the next one. Find a quadratic function whose graph passes through those points. So very similar in the terms of an equation here. Now, f of x, if it helps, I'm going to rewrite over that, think of that as y, and of course our ordered pairs, x, y. So I'm going to write my equations using those three ordered pairs. I'm starting with negative 1, 3. So I'm going to put 3 in for y, and then negative 1 in for x. So negative 1 squared, I'll do that in a minute, b times negative 1 plus c. Okay, let's just simplify. Negative 1 squared 1, a times 1, b times negative 1, and then c. So there's my first equation. Okay, second one, I'm going to do x, y, 1 and 1. So 1 in for y, 1 in for the x's. And I know some of you can just do this and clean it up all in your head. I'm just writing it out so it looks nice for our notes. A squared, or 1 squared 1 times a, b times 1, c. All right, final equation 2, 6. So 6 for y, 2 in for x. So a times 2 squared, b times 2, and then c. Okay, let's simplify. 2 squared 4, 4 times a, b times 2, and then c. So again, I'm just going to section it off. There's my three equations. Now I'm going to work on solving that system. So as always, I'm scanning through the variables. A, 4a, negative b, b, 2b, that's not bad, c, c, and c. Probably getting rid of c's would be the easiest because it would just involve switching some signs. So I'm going to choose to get rid of c's. So I'm going to start with my first equation. Like the last problem, I'm going to flip-flop it. I'm going to put the variables on the left, the number on the right, because that's how we're used to seeing it. And then my second equation, I'll pair up with it, but I'm going to run a negative through it. So negative a, negative b, negative c, negative 1. All right, let's add those up. Oh, a's cancel, we got it. Negative 2b, c's cancel, that's kind of nice. 3 minus 1, 2. b equals negative 1. Hey, I like that answer. Let's use that to help us out a little bit, obviously. So now you might be like, what does that really mean? If that's throwing you off, don't let that throw you off. Let's go through our normal process. We need to do something with equation 3. So I'm going to jot it down. Of course, I'm going to put the variables on the left, numbers on the right. And then I'm going to pair up whichever equation I want, and I'm still going to try to eliminate c. So let's pair up, it doesn't matter, let's do the second equation, but with the negative through it again. So negative a, negative b, negative c, negative 1. So I have my 3a, 2b minus b, c's are gone, 5. Now, here's the nice thing. You might be like, what is happening here? It's actually easier. We got a little lucky. If you know on the left in the red, b is negative 1, let's put a negative 1 in there. I can solve for a in my head. I'm going to add the 1 over. A is 2. So getting that first answer, we really got lucky because it's saving us a little bit of work, my friends. So last thing we need, c. So I'm going to go back to one of my original equations. Pick one. I mean, they're all pretty easy. I don't know. Let's do the top one. Let's just make our lives easy. So I'm going to replace a with 2, b with negative 1, and we're going to figure out what c is. So 2 minus negative 1, that's really 2 plus 1, so 3. Oh, I can do that in my head. C is going to have to be 0, 3 plus 0. Got it. So we've got our answers for A, B, and C. That wasn't so bad. Final answer, though, it asks you to write the quadratic function. So I'm going to replace A in this original equation up here. I'm going to replace the A with 2. I'm going to replace b with -1, so minus 1x. I'm going to put the 1. C is 0. I'm not going to write plus 0. Final answer in blue. Y equals 2x squared minus x. Whew. All right, here's where you might, want to hit pause, go get yourself a coffee, find your inner strength, because we have one more of these to go. Okay? So, final problem. Small corporation borrowed $775,000 to expand its software line. Some of the money borrowed at 8%, 9%, 10%. How much is borrowed at each rate if the interest was $67,000? Gosh, I'd love to make that $67,000 in interest in a year, please. And the amount borrowed at 8%, 4 times the amount borrowed at 10%. Now, we have done these money problems before, but we've only had 2 amounts of money, 2 percentages. So we're just adding more to the problem. Now, we are borrowing money to total up to $775,000. So my first equation, I'm just going to total the 3 amounts, whatever they are, x, y, and z, to $775,000. Just like in the past, my next equation, the interest equation, involves the percentages. So the first percent, 8%, I'm going to put that as a decimal. My second percent, 9%. And the third one, 10%. Okay, and we earned $67,000 in interest. Man, I wish. Okay, here's where the third equation comes from. This is the new part. The amount borrowed at 8% was 4 times the amount borrowed at 10%. So we're literally going to translate that into an equation. The amount borrowed at 8%. Okay, so look at my equations. 8% has the x on it. So that's x. Was. Was is the past form of the word is. Is in math, of course, means equals 4 times the amount borrowed at 10%. So I'm like, okay, 10%, 0.10, that's got the z. So there is my third equation. Now, believe it or not, this is actually going to come out pretty nice for us. Because if we know x is equal to 4z, I'm going to right away replace the x's with 4z. Because that will get me down to a system of just 2 variables, 2 equations. So let's take a look at those. What's going to be my new equation 1? Well, if I have 4z plus another z, I'm going to combo that to 5z. So I'm going to rewrite that as y plus 5z equals 775,000. And then my new equation 2, you might need, of course, a little calculator out for this, because if you put 4z in here, 0.08 times 4z, I'm just going to jot it underneath, 8 times 4, 0.32z. So 0.32z plus 0.10, 0.42z, 0.09y plus 0.42z equals 67,000. All right, that's not looking so bad. I mean, the decimals maybe. Now, here what we have to decide. Do you want to use elimination or substitution? A lot of decimals, so I mean, I don't know if I'm super excited to do elimination on it. I think I'm going to go substitution, plus this just gives me a little chance to review substitution with you. So, top equation, obviously I want to work on that. It doesn't have the crazy decimals. We can pretty much solve the top one for y in our heads. We're going to subtract the 5z off. I'm going to write the 77,500 underneath. I'm running out of room. So I'm going to substitute this in to the bottom equation for y. So let's rewrite that guy. I've got my 0.09, but I'm going to replace the y, of course, with a negative 5z plus 775,000. And then I have plus 0.42z equals my 67,000. All right, algebra skills. Here we go. We're going to distribute. 0.09 times negative 5, of course. 9 times 5, 45. 0.45. Yes, I had to use my calculator for this. 0.09 times 775,000. 69,750. Okay, let's combine our like terms. So I'm going to add those z's together. It's negative 0.03. And I'm going to subtract off the 69,750. Clearly, I'm going to divide negative 0.03 off in my calculator. This is a money problem, so I'm going to label it with a dollar sign, and I'm going to round to 2 decimal places, so I'm in dollars and cents. So there's my answer for Z. I'm going to label that too. Z was at 10%, just to be crystal clear on how much at each rate. Got it. 1 answer down, 2 to go. Now, we can get the other 2, I think, fairly easy. So I'm looking back at the top up here. I'm on the right-hand side. I'm looking at that green expression, y equals negative 5z. I just figured out what z was, plus 775,000. Of course, just literally type that in the calculator. Why do that in your head? Let's get real. Throw a dollar sign on it. 31,600. Oh, so many sixes, it scares me. 65 cents. Got it. All right, final answer then, of course, we need x, which you can pretty much do in your calculator. I'm going back to the original system, back substitution, back through the problems. X, of course, is 4 times z. We know what z is. So literally punch that in the old calculator, and we're going to get, whew, I'm going to throw a comment in there. Oh, let me label that. X was at 8%. Got it. Let me go back, and Y, of course, was at 9%. Let me put a little note on there. Got it. So if you look at your homework, I clearly didn't assign you a lot of problems because they are very time consuming. Okay, take your time, write neat, don't make a calculation error. Good luck, have a great day.